So earlier we discussed how to design a survey or study. Now we're going to talk about how to design an experiment. The first thing we need to know is, what is the difference between an experiment and a study? And as you can see here, an experiment, we try to affect the outcome. And a study certainly does not. In a study, we just look at what happened and analyze the data. In an experiment, we try to change something to affect the outcome. And experiments are used to establish causation. In other words, does this plant food create bigger plants? Let's talk about some terms next. Some of the terms we need to know are experimental units, and these are the individuals that we're performing an experiment on. Now remember, an individual could be people, which we call subjects. Not nice to refer to people as experimental units, but an experimental unit could be, say, a car tire, or a car, or motorcycle helmet. It could be just about anything. And as I mentioned, subjects are human experimental units. Treatment is what we're trying to test. And then a factor is one of the variables in an experiment. Something else that's very important is a placebo. And a placebo is Latin for I shall please. And it looks just like a real treatment, but you give it to a control group. The reason why is something called the placebo effect. And that says 1/3 of the time, on average, people will get better if you give them a fake treatment. And this applies to a lot of drugs, and in fact, cough medicine has about the same level of efficacy or effectiveness as does a placebo, which is kind of interesting. Give me a second to copy this down. Response variable. This measures an outcome of a study. This is also called the dependent variable and an explanatory variable. These are factors and independent variables. So the way to remember them is that explanatory has an X in it. So it's explanatory, and of course response has to be Y. Because when someone asks you a question, your response is why. So that's how you know where to graph your explanatory and your response on a graph. I'll give you a second to copy this down. Some more principles of experimental design, rather. I thought it was terms, but it's principles of experimental design, and there's 3 of them. Control, replication, and randomization. The 3 principles are control, replication, and randomization. And these are the 3 things that you must have in a well-designed experiment. And the purpose of control, confounding effects of lurking variables. So a lurking variable is something that you didn't think to take into consideration. And confounding is anything that can interfere with your ability to look at the information. So let's look at this in a little more detail. Control. We're going to control the placebo effect. So our control group, like I told you before, is to eliminate the confounding effects. Don't confuse control and a control group. Control is how we try to minimize variability, and a control group is a group who gets a fake treatment. So one of the things we can do is to group people. We'll group people to a control group and an experimental group. The control group gets the placebo, and this is done to control for variation. Maybe everybody who gets the placebo feels better. That's going to tell us something. The experimental group is given a real treatment, and then we compare the 2 groups to see if there's any difference. If there's no difference how the control group and the experimental group react to something, odds are whatever that is isn't really the factor that's making a change, but it's something else. Replicate. So why do we replicate something? And it says here replication is not to eliminate chance variation, which we can't do, but we want to reduce its role. We want to use enough subjects to reduce chance variation. And at the bottom there's a little warning in red. Conducting an experiment again and again is called replication, but that's not what we mean here. Replication here means having a big enough sample size. If I tell you that a drug works on 2 people, do you really trust it? What we need is a larger sample, and that's what we mean by replicate. Having a sample size that's big enough to actually mean something. Randomization. We have to figure out who's going to get the control and who's going to get the treatment. Some believe, I believe, this is one of the most important principles of experimental design. This helps us to reduce bias. And we want to try to reduce bias any way we can. So there's a few notes that you can take on here. I'll wait a second, and then I'll go on. And then here are some different ways where we can compare things. We have a treatment and then an observation, a treatment, and then another observation. Sometimes we want to look at something, apply a treatment, then look again. And here's an example of a completely randomized experiment. We have 30 rats. We've divided them into 2 groups. One group gets a new diet, and the other group gets a standard diet. So this bottom group here, even though they didn't get a placebo, they still did get something. They got their standard diet, whatever they normally get. Then we compare the weight gain. We want to see, is the new diet, the treatment, better than the old diet, the control? And we're going to compare the two. I'll give you a second to copy down this diagram. Okay. Blindedness. A single blind experiment, the subject does not know what treatment they're receiving. And then a double blind is where the subject and the researcher, neither one of them knows who gets the placebo, who gets the real treatment. This helps us to avoid any unconscious bias that we may have. And of course, the subject can never know what they're getting. If you tell somebody they're getting a placebo, it's not the same as just giving them a placebo and making them think it's real. The gold standard really is a double-blind test. If it's not at least double-blind, it's probably not worth a whole lot. Blocking. So here's what we're going to want to do. We want to set people who are similar up in blocks. So a block to an experiment is like a strata to a survey or a study. So a block is kind of like a strata. Maybe we want to put we want to compare males to males and females to females. In experimental design, that's called blocking. And in a block design, as you see at the bottom, it says that first we block people, then we randomly assign people, or experimental units, inside of this block to either control or treatment. And we compare each block individually. We block to control for some variables, and you can read this. You might want to pause the video here in a second, but in this example we're trying to see, does exercise impact cholesterol level, does a pill affect cholesterol level? And we're going to block subjects by how much they exercise. So I'll let you read this and then we'll go on. The last thing we're going to talk about on this video is matched design. And really what you do is each person gets a treatment and they're also a control. So they're given a treatment, a real treatment, and a placebo. The groups are going to be split. So half the people are going to be treatment first, and then control. The other half are going to be control and then treatment. And at the end we're going to compare. And we're going to see a difference between the control and treatment for each individual person. So people are their own controls. There's a lot of different experiments that I've seen set up this way, and this is actually a very good way of setting some things up. I have an example coming up that we can talk about. Here's an example. And in fact, some of my students had this exact experiment they had set up, so I'm pretty familiar with it. What they wanted to do is they wanted to test to see, can people read the same speed with and without listening to music? Since some people are better readers, each person was their own control. So when a person walked up, they had a way to randomly determine if a person was going to read without music first or read with music first. And they compared their reading times with music and without. But this way, each person was their own control. And at the end, the data was inconclusive. It could not be determined one way or the other if reading music helped, or reading with music made you read faster or slower. So it was actually inconclusive for this one. But that's the way it was set up. People were compared with music, or their reading times with music and without music in this particular design. So I'll pause for a second, let you pause the video, whatever you need to do, and if you have any questions, please make sure you ask me in class.